Alright, welcome to part 3 of our lesson on polynomials. In this video we will focus on direct substitution, which is pretty simple, and we will talk about how we describe the end behavior of a function, the connection between end behavior and degree and the leading coefficient, and then we'll wrap the video up with some function analysis. Okay, all the vocabulary characteristics. Okay, but for now, let's look at problem number 10. Using direct substitution to evaluate. Now, direct substitution, that's where you take the value and you literally substitute it for the x's. So, we're supposed to evaluate for x equals -1. So I'm going to substitute -1 for all these x's. So that means I have 7 and it'll be -1 to the 4th power, then -3 times -1 to the 3rd power minus -1 squared minus 4. Okay, normally I would just put this whole thing into the calculator and just hit enter. But because it's just a -1, it should be really easy to do by hand. We know if we have a -1 to an even power, then it's going to be a positive number. Okay, so basically this is just going to be a positive 1. If I have a -1 to an odd power, it's going to stay -1. Okay, again, -1 to an even power is going to be positive 1. Okay, so that means 7 times 1 is just 7. -3 times -1 is positive 3. Okay, and then -1 is just -1 and -4. Okay, so 7 plus 3 is 10. Minus 1 is 9. Minus 4 is 5. Okay, so that's it. That's going to be 5. If this were something more complicated than a -1, then I would have just started typing all this into the equation, into the calculator. Okay, like for example, what do we have here? So 7, -1 to the 4th power, so it would have been like, yeah, 7 times -1 to the 4th power. And -3 times -1 to the 3rd power. Alright, minus 3 times -1 to the 3rd power, and so on. Am I committed? I guess I might as well finish it. Minus -1 squared minus 4. Okay, you could just type it all in and hit enter, and you get 5. Okay, there, I just did the same problem twice for you. You're welcome. Alright, now, what about number 11? Describing the end behavior for each of the following functions. Okay, so we're talking about a function that has degree 8 and a leading coefficient of 1/2. Okay, degree 8, leading coefficient of 1/2. The significance of the degree being 8. Okay, the key is that this is even degree. Alright, so when we have an even degree, we know the end behavior is going to be similar to, well, the end behavior is going to be just like a parabola. It'll either have this type of end behavior or it'll have this type of end behavior. Okay, now in truth, degree 8 is not a parabola. Okay, a degree 8 polynomial is going to have other kinds of bends going on, but still the end behavior is going to match. Just like a parabola, it'll be either both up or both down. Okay, that's the key. Now, the way we know whether it will be up or down is because of the leading coefficient. Now, the leading coefficient being 1/2, it really doesn't matter what the number is. The important part is that it is positive. Okay, because it's positive, we know to go with the positive version of the end behavior. Okay, not the negative version. Okay, so we know the end behavior should be that it rises on the left and it rises on the right. Okay, so that lets us know it rises on the left, it rises, so infinity. As we go to the right, it rises, so another infinity. Okay, if it falls, we'll say negative infinity. So take a look at part B here. Alright, now we're talking about a function that has degree 5 and a leading coefficient of -4. So I'm just going to change colors for a second. So on this one, the degree being 5, the significance of that is that it is odd. Alright, this is an odd degree. Now when we're dealing with odd degree, we know that it has end behavior like a capital letter N. And this is your basic shape of a cubic, which is also odd. But all odd degree functions have similar end behavior. Okay, now this is the positive version, like a capital letter N right side up. And the negative version looks like this. Okay, like an upside down N. Okay, now the way we know which one it will be is because we will look at the leading coefficient. And the important part is the sign. So it doesn't really matter whether it's a -4 or -5 or -1/2. The key is that it is negative. So that lets us know, as far as the end behavior goes, it'll have end behavior like an upside down N. Okay, the negative version. So it won't be like this. Okay, now in reality, it's not going to have end behavior. No, it's going to have this end behavior, but in reality, this is not the graph of a degree 5. Okay, a degree 5 actually looks like this. Okay, in general. So there's my degree 3. So a degree 5 will actually have an extra bend in it. Now, it's not important right now that you know just exactly how many bends there will be depending on the degree. But I just want to be clear. I don't want you thinking that odd degree functions all look like an N. It just has the end behavior of the N. Okay, so on the left it rises, on the right it falls. Okay, so as we go to the left, it rises, so there's a positive infinity. As we go to the right, it falls, so that's a negative infinity. Okay, so that was number 11. Alright, let's go ahead and end this video here, and we will go with the characteristics of functions. We're going to analyze the absolute, maxima and minima, zeros, y-intercept, end behavior, intervals of increasing and decreasing. All that will be on the next video. Stay tuned. I'll catch you then.